Hello everyone, this is Hossein Mokhtarzadeh and we want to talk about the sport biomechanics. Hopefully this simplification of sport biomechanics could help you. So, sport biomechanics deal with two major parameters. We talk a lot about in this course, forces and moments. As I can see, people talking a lot about biomechanics of a sport, but some fundamental are not being well understood in my opinion. So let's just start talking about some fundamentals, and when we learn it, we'll see that this can actually shape the way we look at human performance and injury. So what we want to do here is we try to stop guessing, just looking at someone, say, oh, it might injure you, this activity, or that activity might help you or might not help you. So we just want to know why this is happening. So if you look at, for instance, people, let me just stop this so you can see well the whole idea here. So if you look at someone doing a squat, someone is doing it and they make great muscles and they enjoy it, but someone else does it with lots of pain after that, and even sometimes with a kind of injury. Is it anatomy? Is it the way they're doing it? What is it? Is it the weight they're doing it? That how big or how small it is. So why do you think? Just keep thinking about this so we're gonna answer some of these questions. To answer such questions, I don't think we need necessarily go through some of the deep scientific work, as you can see on the right hand side, and know exactly what's happening in every single muscle, and bring people into laboratories that are from $100,000 to $2 million to sort of understand what is going on. There are easier ways to do that. So we're going to learn some of these ideas here. So the secret is these two. Whatever you do, we do, for instance, in a sport or any kind of movement, comes down to these simple ideas. Forces, moments. You may have heard them. Moments, also people call them torques as well. All right? What they are. Let's just go deeper, a little bit deeper into these. So force is quite simple, right? You can just push and pull. Whenever you push and pull something, that's basically generate force. You apply force. You walk, you just touch the floor, right? So you have a force that goes through the body, through the ground, and the ground actually has got the same forces to you, right? You remember Newton's law. So it's basically either push or pull. And think about it. What muscles are doing? Are they pushing or pulling your bones? Think about it. But before going through deep into that, just know that pulling and pushing is just basically forces. And what moment means here? When we talk about moment, it's actually how the forces acting when they are away from, let's say, a point. So what do I mean? For instance, here what you want to do is you want to open this door, right? You have a handle. So if the handle is small and the door, they call it the axis of rotation around. It's not talking about the whole door here. I think we're talking about here just that the handle and how we can easily open the door, right? So if it is a small, so you basically need more forces versus when you have it the distance. So if you have 1 meter away, then it will be quite simpler. So you can see that for moment we need two things: forces you apply, right, and the distances from that particular point, right? So that's the moment, force times distance. We'll learn more as we go. So have a look, an example here. You have noticed that if you are lifting your weight these two, which one might be easier? The answer is here, of course. So if you have the same load, they have the same weight, is the left side or right side easier? So based on we have moment, forces. So the force is quite the same, right? The forces is the weight of that, and the moment arm. When we say moment arm, we're talking about this distance, the right angle, right? From the force, which is the mg, which is the weight of this, to the center, let's say, of the joint, let's say, okay? This is bigger than this angle, this distance, right? So when we say this is bigger, so which means that the forces are the same, the mg like F forces of the ground, the moment arm is smaller here, so the moment that you feel is smaller. So what does it mean? The moment you feel is basically like, imagine you have a motor here. Yeah, you didn't imagine you didn't have it. It was like a robot. So you needed to sort of overcome this force, right? Which was a kind of like a torque or moment. So it's just like a rotational force, right? That you needed to apply. That comes from your muscles, of course, right? So we'll learn as we go, but for the time being, note that the distance is smaller, so the moment is smaller, so you feel it less, okay, in terms of the stresses or loading that your joint feels. So joints are amazing. We have joints. That's why we can walk. We can do different activities, right? So the joints feel not just the load, right? They feel the moments as well, and the moments come from muscles. The majority of them. It comes from other tissues as well. So if you have like high like the moments, it may load other structures, like your ligaments, your like the tissues or the soft tissues, right? And for instance, the high moments for why some people would get backache or back problem or even disc, for instance, issue they are lifting, it would come down to the high moments because of the muscles. And then those kind of moments also can turn into like a loading. We'll learn as we go as well. So don't worry about it. Just for time being, understand that these are related to each other. Okay. So the whole point is optimizing the moment, and of course the force as well. But we'll talk about what it is, like the force and moments, how they are applying to the joints, and how they can help or not really helping. So, so this course in general, we're trying to avoid just guessing. Say, oh, how can I help this person? Like you are a coach, you're an athlete, so you want to lift a weight. Say, how does it work? Like, I really don't know if this is really helping you, not helping you. You'll injure yourself or not, you know. But if you learn at least these two concepts, moments and forces, you can somehow get the ideas that okay, how big is the moment here? For instance, if the distance of the load is greater versus to the point that like your back or your knee joint, for instance, so you see that if the forces are the same, the lift you're lifting, so you know that the moment will be huge, and then your muscles are compensating for them, so that the loading will increase, then the risk of injury will increase, right? So don't worry about it if you don't get it at this stage, but that's the whole idea, all right? That is, this course will help you. So what I'm trying to avoid is like I'll go in there and say, look, there's like amazing labs, equipment, and complex things, equations that you need. No, we're not going there. It's just a few simple ideas that we will talk about, and then really avoid any mathematical or physical equations, physics. So you'll understand the root causes, some of the basic physics and forces and moments ideas, and then you gain skills that you can just use the day after or right away. Okay. So we talked a little bit about like, oh, we try to avoid the guessing and start understanding and what the concept of force, which is like a push and pull, right? And the moment, why distance matters. We somehow looked at it. And the biomechanics in action, which is one say, okay, what is the injury risk and the technique, how they are related to each other, and how you can take it from there. You know, biomechanics is huge and people are doing amazing stuff. But some fundamentals, if you don't know them, or if we do know them, it can help us a lot, not necessarily knowing, for instance, oh, super duper model out there, how we can help them, or what that specific muscle is doing. That's good to know. But if you know the general ideas of moments and forces around each joint, you can tell a lot about potential injuries, risk of injuries, and so on. So let's stop guessing and let's start understanding the language of movement.